For today, transforming functions. We want to just put some vocab down, even if it's that tiny on the board. It's written on your papers. So let's start with translation. And as I said, today is the 26th. So a translation, this is simply a vertical or horizontal shift. So we are going to pick up the parent function and move it up and down, left and right. That's what it means to be a translation. We're going to pick up our parent function, move it up, down, left, and right. Yes?
It's kind of like what we did, where the graph was like a V.
Yes, this is identical. I'm repeating the exact same words, vocab, letters. It's all the exact same information, yes.
Okay.
So if you remember that, today's going to be super easy. Reflection, this is simply a mirror image across a line. And we're going to stick with vertical reflections. Yes, we could do horizontal reflections, but for our purposes, they're not as interesting. We're going to stick with vertical reflections here. And then a stretch or a shrink, the easiest way to think about this, our parabolas are U-shaped, right? So a stretch, this is going to be a narrow graph, and a shrink, this is going to be a wider graph. Right, so when you stretch a graph, that means the edges get closer and closer together. Or if you think about, like our example, our warm-up problem today, we had the 2 in front. So that meant instead of going up 1, right 1, we went up 2, right 1. That's a vertical stretch. The y values are getting drawn out and the x values don't change. All right, so this absolute value graph that Johnny just mentioned, that's what we're actually looking at. So I want you guys to take maybe a minute and a half with the people around you, talk about what A, H, and K mean. Okay, so in an absolute value, A changed the slope. Keep going.
And then H is like the horizontal movement of the vertex.
Okay, so let's stop there. So this is a horizontal shift. We're going to get into more detail in A in a second. So horizontal shift. Okay, we're going to keep going, Jack?
Sure. And K is vertical movement of the vertex.
Okay, so let's add a little bit more detail here. So since we already have the H part written down, so H is a horizontal shift, that's left-right movement. K is vertical shift, up and down movement. With the horizontal shift right here, what do we need to add to make sure that we really understand how we're shifting this, Alex?
H when it's a negative and you go to the right, and it's positive and you go to the left.
Okay, x minus h is to the right. X plus h is to the left. Good. So that's opposite what we think. So make sure that you jot a note to yourself to remind you when it's x minus h, you move to the right. When it's x plus h, you move to the left. But the k values don't change. So positive k means, so for example, positive 2 would mean you move the graph up 2. Negative 2 would mean you move it down 2. Okay, so in an absolute value, the A did change the slope. But we want to make this more general terms. So really what we could say, and it's really just this stretch shrink, when A is greater than 1, this made the graph narrow. Graph narrows, which we saw in our warm-up with an A value of 2. When it's just a fraction, so we've seen examples of 1/2. When it's a fraction like this is going to make the graph wider. And if we think about what's missing here, a negative A value is going to reflect the graph or flip it down. Okay. So these are this is the same information we wrote on the board with absolute value functions. So H, horizontal shift, K is a vertical shift, right? A changes the almost kind of the shape of the graph. It gets skinny, wide. Now there's one other piece that we need to remember because an absolute value has a vertex and so does a parabola. So the vertex in this problem was at the point h, comma k. Right? We just simply looked at h, put the h value in, looked at k, put the k value in. That's how we found the vertex. Once again, this is a general statement. It's also going to be how we find the vertex for the vertex form here. Alright, so this is all repeating that information. So let's write down what this vertex form is. And so make sure this stands out on your paper. Highlight it, star it. Y equals A times x minus h squared plus k. Your vertex is still at h comma k. H is still a horizontal shift. K is still a vertical shift. A still does the same stuff to the graph. So this should look really similar to absolute value. The only difference now is what we're doing, what the function is. The function is squaring instead of the absolute value. But everything else we do is the same. So how you find your vertex, you simply look at your h and your k. That's your vertex. Right? How would we find the other points then? Now we're talking a parabola. Ignore the absolute value. So once we find the vertex, which is at h comma k, how do you find the next points? Yeah.
You just follow the pattern from before.
Follow the pattern. So we're going to go up A, right 1, up 4A, right 2. Maybe it doesn't hurt to write that again. Up A, right 1, up 4 times A, right 2. Get some work on the board. Felix, give us the first one.
-2 and 1.
So it's not -2.
Oh, it's 4.
Yeah. 2. It's opposite what we think, right? So when it's negative, it's a 2. When it's positive, you write -2.
Wow.
So it just follows that, what we were just talking about, right? So your vertex is always at h comma k, right here.
Mhm.
And the equation is x minus h. So the minus is built into the equation.
Oh.
So when you're given a minus, it's already there. So you just simply write the number.
Okay.
If it's a plus, then you have to change the sign. All right, Tyler, give us the next one.
-3, 2.
All right, Ethan, give us the next one.
1, -4.
And Miles, give us the last one.
I didn't get the last one.
We're coming back to you then later, Grace.
-5, -3.
-5, -3. There we go. So, Miles, just the vertex for part A.
1, 2.
1, 2, that's right here. And then we count our points. So, Jack, how are we going to do that with this one?
Up 1, right 1.
Okay, and then the next right side point is?
Up 4, right 2.
There we go. And then I'll reflect over on the left side. Whoops, that one's too high. Here. There we go. Right, and that's about how long the graph should take us once we get used to these. So, Sam, what about the vertex for part B here?
-2, 1.
Okay. And then, Stuart, doing the same thing, how are we going to count our points? Just deal with the right side.
Up, down 1 over 1.
Okay, and then?
Down 4 over 2.
There we go. That's the right side. I'll reflect over here to the left side. There's our parabola going down. Johnny, vertex for part C.
2, 4.
2, 4. Okay. Dawson, count our points for us, please.
Down 2 over 1.
Okay, and then the next one?
Down 8 over 2.
All right. There's the right half of the graph. We reflect them over then here and here. There's the other side. Let's keep this going. Lily, vertex for part D, please.
-2, -6.
Down here. Okay. Ellie, count our points for us, please, on the right side. And then the next point?
Up 12 over.
Looks like this. All right. Hannah, vertex for part E, please.
1, 3.
1, 3. Okay. And then, Alex, can you count our points? reflect that over here, here. There we go. That's a wider graph. Aiden, vertex for the next one.
-4, 4.
Okay, -4, 4. And then Parker, can you count our points for us, please?
Down 1 over 1, and then down 4 over 2.
And then we reflect them over. There we go. Formula, or a vertex form, really, and adding in these new parts. So this first one, we're shifting the parent function down 3. What does that look like? Xavier?
Y equals x squared minus 3.
There you go. The -3, right? That is the down shift. So -3 tells us to go down 3. Next one. Yeah.
Wouldn't x squared be in parentheses?
I mean, sure, it doesn't matter though, because there's nothing around it. So you don't. It doesn't have to be. It doesn't. That doesn't do anything to the graph. Next one. Miles?
Y equals x minus 4 squared minus 5.
There we go. So right 4 tells us that it has to be on the inside of those parentheses because that's where the horizontal movement is. And when you move to the right, we use a negative, right? It's opposite what we think. All right, and then lastly, we have this one we want to change. Okay.
Oh, just see answer.
Yeah.
Oh, okay. 2 parentheses x plus 1 squared plus 1.
All right. So we're shifting to the left 3. So we had the vertex at -2, 1, which is kind of, we're here. And then we're shifting, yeah, that's, oh, sorry, +2, 1. I wrote it down wrong. +2, 1, and we're shifting to the left 3. So we just move over 3 units, and that would bring it to -1, 1, right? So that's kind of how you can think about this one. So we're shifting to the left 3, so that has to go from -2 to +1 there.